This video will explain how to troubleshoot and solve the problem when a picking error occurs on site. In the previous two videos, we discussed two things. One is to introduce factors affecting picking accuracy. The other is how to guarantee qualified picking accuracy during project deployment. However, during the long-time production, the issues with imprecise robot picking are inevitable. When such issues occur, we can troubleshoot them according to the following process. Based on the most likely factors affecting the picking accuracy, here's a simple process to troubleshoot a problem. First, check the point cloud quality. View the point cloud of objects to be picked in Mech-Mind viewer. If the point cloud is obviously missing, its quality needs to be improved. In a site with stable production, the point cloud quality problem is mainly caused by changes in the on-site light. For continuously stable production, shade the light in the workstation. Then adjust the camera parameters for a complete object point cloud. Second, if deep learning is used, check the recognition results. The results can be viewed through the production interface. If they are not satisfactory, try changing the 2D exposure parameters or adjusting the 2D ROI. If the problem persists, consider retraining the model. Third, check the 3D matching results. The production interface also provides a 3D matching view. When the match is inaccurate, the parameters or even the recognition strategy need to be adjusted. For this, please contact support engineers. After completing the troubleshooting steps above, test run for a period of time. If there are still inaccuracy issues, continue with the following process. Check the hardware. Check the camera mounting frame for deformation or shaking. If there is deformation or shaking, replace the camera mounting frame. Check whether the robot is securely mounted. If it's mounted loosely, timely reinforcement is required. Then check the gripper for deformation. Check the gripper TCP deviation using the fixed point teaching method. If a deviation is found, it indicates gripper deformation. Thus, repair the gripper and update the gripper model in the software. Additionally, recalibrate the TCP. After confirming that the hardware works properly, check the intrinsic parameters of the camera under the guidance of Error Analysis tool. In Mech-Vision, under Toolkit, there's Error Analysis tool. Select Camera, click Check Intrinsic Parameters for the detailed procedures. Follow the instructions shown, open Mech-Mind viewer, connect the camera, click Intrinsic Parameter tool under Tools, check intrinsic parameters referring to the process. If the check fails, handle the problem as prompted. If the problem remains after handling, please contact technical support engineers. Once the intrinsic parameter check is complete, navigate back to Error Analysis tool. Click Extrinsic Parameters. In the case of eye-to-hand setup, click Analyze Extrinsic Parameter Error in eye-to-hand setup. Follow the instructions step by step. First, build a project to obtain calibration board poses. Then, synchronize the pose of the real robot and obtain the calibration board point cloud. Next, create virtual TCP. Make sure it coincides with the circle center on the calibration board. Finally, move the real robot to other positions in the workspace. At the same time, obtain the calibration board point cloud. If the TCP always coincides with the circle center on the calibration board, extrinsic parameters are qualified and this process can be ended directly. Otherwise, the robot accuracy needs to be checked. In the case of eye-in-hand setup, click Analyze Extrinsic Parameter Error in eye-in-hand setup. Follow the instructions similarly. Then, check the robot absolute accuracy according to the guideline in the Error Analysis tool. First, check the 0 positions. If they are lost, please recalibrate. Next, control the robot to move a certain distance along a fixed direction in the workspace. Meanwhile, measure the actual distance. Compare it with the distance displayed on the teach pendant. A smaller difference means a higher robot accuracy. If the accuracy cannot meet the requirements, please contact the robot manufacturer. At this point, the check is complete. Throughout the whole process, whenever a problem is found, the extrinsic parameters are to be recalibrated at the last step. Now the error checking is done. We can also navigate back to the dashboard of Error Analysis tool. This can help us quickly locate the problems based on the specific situations described. For more detailed methods to solve the error, refer to the documentation link below the video. Through the above process, most of the picking errors can be solved. If there still exist errors seriously affecting picking, please contact support engineers.